So let's rationalize the denominator of the following example here. Now, when it comes to rationalizing the denominator, they're talking about getting rid of the radical that is in the denominator. So if you have a radical, it's not considered, if you have a radical in the denominator, it's not considered simplified. Now, that could look a few different ways. Like you might have a radical, maybe that looks something like this, 4 over the square root of 5. You might have something like our given example here. And depending on what the denominator looks like is going to make a difference on how you rationalize the denominator. If you have a single radical like this, you would rationalize the denominator by multiplying the numerator and denominator by whatever that radical is. So over here, I had a square root of 5 in the denominator, so I would multiply by square root of 5 over square root of 5. Keep in mind that fraction multiplication is straight across. 4 times the square root of 5 would just be 4 times the square root of 5 over the square root of 5 times square root of 5. So there is a rule for radicals that says that the same square root times the same square root is just going to equal what's underneath. So like square root of 2 times square root of 2 is just a 2. So square root of 5 times square root of 5 is just a 5. And that would be our answer if we were rationalizing something like that. Now, in our example, our denominator is a little bit different. We have 7 minus the square root of 3. When you have something like this, a number plus or minus a radical, in order to rationalize the denominator, you need to multiply by the conjugate of the denominator. Now, the conjugate of something, if you're giving something like a plus b, the conjugate would be a minus b. If you were given a minus b, then its conjugate would be a plus b. You're going to drop down the same terms, but change the sign in between it. So for us, the conjugate of 7 minus the square root of 3 would be 7 plus the square root of 3. So anytime you have something like that, you're going to multiply numerator and denominator by the conjugate. So that's going to look like 7 plus the square root of 3 on the top, and then 7 plus the square root of 3 down here. And you're going to want to multiply that out. Numerator times numerator, 3 times this, which means we're going to have to distribute that. 3 times the 7 is 21, plus 3 times the square root of 3 is just 3 times the square root of 3. Put them together. They don't blend, so you just put them together and drop down. Now in the denominator, we need to multiply this out. Distribute the 7. 7 times the 7 is 49. 7 times square root of 3, again, they don't blend, drop them down. 7 times the square root of 3 is 7 times the square root of 3. Now distribute the negative square root of 3. Negative square root of 3 times 7, or 7 times the negative square root of 3, is just a negative 7 times the square root of 3. Drop down the sign. Again, they don't blend, drop them down together. And then negative square root of 3 times positive square root of 3. A negative times a positive is negative. And same rule here, square root of 3 times square root of 3 is a 3. Now a little bit of cleanup to do here. Notice on our denominator, we have a positive 7 square roots of 3 and then a minus 7 square roots of 3. 7 minus 7 is 0. This is going to disappear. It's like saying 7x minus 7x. Well, 7 square roots of 3 minus 7 square roots of 3, you don't have any left. So in the numerator, we have a 21 plus 3 square roots of 3. And in the denominator, we have a 49 minus a 3 makes that a 46. And that is how you rationalize the denominator for this given example.